All right. So this is our PlayPosit version, and what I was trying to do was wait to see student work so that you guys can decide if this is accurate or not. So it's a little bit different than if you completed the TGA with me in class or independently watching the class recording or just independently altogether. Now you are welcome to pause and go take a look at Desmos to decide if our classmate is correct. So our function is a cube root. Let me know if you need help graphing that. Remember, we go into Desmos, we click on functions, and I'll show you that in a second. I have to show you. I can't not show you. Okay, but if we didn't use Desmos, we've got some graph transformations. Let's pull that up. There it is. Okay. So now function notation of transformation rules will apply to various functions. That's just the rule of whatever we're doing to our x. That one was a cube root. It'll work with an absolute value and it will work with a quadratic. So now let's take a look at these rules. Boom. Look inside of here. It's inside the function. So in our case, in our classmate's case, we have the cube root of x, right? That's our function. You'd say f of x, a regular function, the parent function, mom, dad, right there. Now we had our new one, or the one that they were graphing, was x minus 2. Notice, though, it's inside. It's right next to the x. So look over there. Horizontal translation right, see units. Now it's up to you. I'm going to draw the parent function, and you tell me, did the student correctly transform? Why won't it work? Turn it off over here. Okay, well, plan B. No, we'll go ahead and go to Desmos. I was going to draw it, but we won't. We'll go to Desmos calculator. We will do the cube root because I need to show you that. Let me move this. Right down here is where you will find it. If you want to think way back to rational functions and their exponential equivalents, I'll show you that. X raised to the 1/3 power, there's that red graph, is going to be the same thing as functions. Scroll down all the way to the bottom, the nth root, 3, the cube root of x. See, the blue and the red graph are the same. Two different notations for exactly the same function. One is a rational, a ratio, a fraction in the exponent, with the root being the denominator under. Roots grow underground, so the root goes under the denominator, or it goes under the rational bar. Same thing as the root is on the outside of the radical. Those two are exactly the same graph. They're exactly the same function. It's just this different thing. So anyway, that's just prior knowledge, future knowledge. Great. So if that's the parent function, meaning that's what it looks like normally, here it is right through the origin, right? And our classmate has x, the cube root of x minus 2. Minus 2, look at this. Minus c, right c, goes through the origin. And they have it shifted over here. Don't worry about this shape. I'm not too concerned with the shape being like this. See it up there? Not too worried about how the shape looks versus our classmates' shape. No. Right? It's like kind of like an S. That's the gist of it, right? Like an elongated S. That's good enough. I want to know if this point is correct. So you decide, you tell me, and remember, you can try this again and you can retake this. Okay, next one. Question 2, we're going to graph this function. Is that an absolute value? How do we know if it's +1 +2? What's going on? So remember, okay, it won't let me draw on here. So let's go back to this. we have a different information. Let me slide over so I have some more writing room. If we have the absolute value of x as our parent function, but suddenly, I need like more colors. So let's change it. We have our transformation of, we have, what did we have? I forgot. +1, +2. Okay. On the outside, we have a +2. On the inside, we have a +1. I want that to be brighter. +1. Then our original one was x, and that's a 1. Sorry. And inside of here. So now what's happened to our changes? It looks like inside we have an f of x +1. That's what's happening right here. On the outside, we now have this +2, but it's on the outside of our function. I don't know if that's making sense to you, but that's what's happening with transformation rules. So now you have to decide, what does this +1 mean? +1. What does this +2 mean? +2. And let's go see if our classmate did a good job. Really quickly, we'll go to our Desmos calculator. We will now take this. We will open this up. We will turn these off, and we will graph absolute value of x so you can see where the original vertex is. There's the original vertex. Nothing else is being changed besides what we saw on those graph transformations. So now you decide, did our classmate accurately move the vertex? You're welcome to graph it in Desmos, pause before you answer, and see if this location moved to the right spot with those transformations. Let's take a look. +1, +2. Here's the original vertex. So our student went up 2 and to the left 1, and there's the vertex. Don't worry if it's not perfectly straight. It doesn't really matter. That's kind of the key detail. The slope is accurate, right? Up 1 over 1, up 1 over 1, up 1 over 1. Same thing, but this is a negative slope, so it's like downhill, right? It's pretty good. I know it's not perfect, but down 1 over 1, down 1 over 1, down 1 over 1. I'm not grading on that. I get the gist. It's hard enough to write on these. So hence the PlayPosit option. So you tell me, was this one correct? Did it need to be over different? What do you think? Look at the rules. You make your conclusion. Yes, correct. No, incorrect. Here we go. Okay, suddenly we have a negative now. We have an x -2 squared and a +4. Great. Let's go over here. Let's remove this. Let's use this to start. If we just have f of x, this one might start, hopefully this is starting to come together, x squared. That's it. That's our function, x squared. So now, let's break it down one step at a time. This negative out front, negative x squared. That's a reflection over the x-axis. Okay, let's add our next step. We already have our negative. We have our x. Now we had them, I forgot, -2. -2 squared. That's inside, 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 -2 right C units. And then the final transformation, I love oranges, but they just don't have a good bright orange in this one. Okay. Negative, the reflection, our horizontal translation, -2 squared, and then suddenly +4. +4, the final transformation of our graph. Boom, boom, boom. There's the steps, so check those steps out. It says it's a reflection. We move right, we move up. A regular parabola, let's go back to that teal. A regular parabola, and I'll go graph it for you, has a vertex at the origin. It's opening upward. Okay, it's supposed to go through the origin. Okay, I'll show it on the other graph. What I'm talking about when I say regular, we call it parent function, just the good old parent function of x squared. Let me turn off the green one. There it is. So you're looking for that reflection. Boop. What happens with a reflection? You can try it here, right? Try it. There's that reflection. You'll need to be careful when you start to type the rest of it, right? Because it will change in a different way depending on how you type it. You might need parentheses as you begin to type your changes, right? Okay. All right. Now you decide. Did our classmate nail it? Was this a good, for the most part? Obviously, we're not too concerned with, let's see. Let's see. So it looks like it's a reflection, and the vertex is about +2 up 4. Okay, so I'm going to give it, obviously, I'm pretty sure that's, boom, boom. You can look at these two. Are those correct? Go graph this exact one. Tell me, is this correct? Is this correct? Let's go ahead and do this one. We had the -2, and then we had arrowed over +4. Ooh, pretty close. Pretty close. Pretty close. Spot on, right? Okay. Thanks, you guys. I hope this was a good use of your time. Well done. Thank you for your feedback that you like PlayPosit. Remember, I want you to think and just exercise those thinking skills. Try to get them right. Try to get them right. Thank you for watching. There's going to be a little video about mistakes and how important they are. I hope you stick around and you watch that. But if not, feedback about these PlayPosits is always welcome. And anything that's going to help you learn in math class, I am open to suggestions, ideas, feedback for what benefits you guys the most. All right. Thanks for watching.